Welcome, students. So this is the last part in the module 5 as we have a case study, the Linux system. This is Pradeep Kumar from Department of CSC, KJ Institute of Engineering and Technology, Mangalore. So in this case study, so we are covering these topics. So we'll get into little bit Linux history and the design principles, kernel modules, how the processes are managed via process management, scheduling, memory management, file systems, input and output, and IPs, inter-process communications. So these are the topics we are covering as a case study with respect to Linux system, Linux operating system. So these are the major objectives of this particular chapter. So we are trying to explore the history of Unix operating system from which the Linux is derived, and we'll trace out the principles which Linux is designed upon, and we'll try to examine the Linux process model, how it works, how it schedules processes, and how it provides IPC, inter-process communication. And then we'll try to peek into a memory management of Linux, and then we'll explore how Linux implemented different file systems and how it can manage with the different IO devices. To start with, we'll begin with the history. Linux as a good operating system is a free operating system. It is based on Unix standards. It first developed as a small self-contained kernel for a small machine in 1991 by Linus Torvalds, with the major design goal of Unix compatibility. Then the history has been uh, collaborated with many users from all around the world. So each individual user contributed into the development of the Linux platform. So as based on a Unix standard. So then they come up with the efficient and reliable a common PC hardware so they can design for a particular common hardware capability, and then so based on that particular hardware capability they can run variety of applications on different other platforms as well. So the major core as a Linux operating system kernel is exists free Unix software in that, and so that it can it is a very much Unix compatible operating system, saying that it is free from proprietary code. But many varying Linux distributors we have, including the kernel applications and management tools. In general, it is a open source, freely available. Even if you are interested in a development, you can download and you can add on your own additional things or additional components into the existing one, and then you can launch it as it is Unix compatible. And coming to the Linux kernel part, as different versions. So initial, when it was developed initially, when there was no networking at all with the 386 80386 compatible processor machine on May at around May 1991. So they had very limited device support, device drive support, and at that time it was something like a mini computers. So then something they called as Minix file system as well. So later on, after the addition of some major components into that, some processes into the existing one, Linux 1.0 or 1.0 is launched in March 1994, which included support for Unix standard TCP/IP networking protocol, and then BSD compatible socket interface for networking programming for networking, and then they had device driver support for running IP over an Ethernet. Then enhanced file system. They had support for a range of SCSI controllers for high performance disk access, which had extra hardware support as well. And then still few more developments are added into that. And in March 1995, as version 1.2, as the final PC, that is only Linux kernel, was launched. Then coming to the June 1996, 2.0, Linux 2.0 added two major new capabilities with that. So it gives support for multiple architectures, including a fully 64-bit native alpha port and multi-processor architectures as well. Along with that, some of the other features like memory management is added, and performance of TCP/IP is improved, and support for internal kernel threads, and easier methodology to handle dependencies between loadable modules, loadable components as well. And they added automatic loading mechanism, then standardized configuration interface for all. It has been added in that Linux 2.0 in June 1996. Along with that, at that time, Motorola has also come up with the new machines, and then Sun Microsystems or Sun Spark systems and Power Mac machines were available with which is cope up with this Linux 2.0. After that, 2.4 and 2.6 has came up. Both these 2.4 and 2.6 increased SMP support, added journaling file system, and a preventive kernel, which added 64-bit memory support as well in that 2.4 and 2.6. Coming to Linux system, so which uses many tools, as it is developed by Berkeley's BSD operating system. BSD is nothing but a number of processes can be executed at the same time. And then MIT's X Window system and the Free Software Foundation GNU project. So these are the major tools to develop as part of BSD operating system. So these are the different operating systems developed based on Linux as well. And then the system libraries were started by the GNU project. So as it is a part of or a part of Linux community as well, so they provided improvement in the performance level, improvement in the component level, improvement in the module levels of Linux environment, and they added networking administration tools as well, which were derived from 4.3 BSD code. So recently, there is free BSD have borrowed code from Linux in return. But the Linux system is maintained by a loose network of developers collaborating over the network, with a small number of public FTP sites acting as de facto standard repository. There is no standard, or there is no clear-cut differentiation between different network developers, so that they can each can collaborate together. It's a small number of contributors into the development of this particular system. And coming to the distribution part, so nowadays we can see several distributors in the market for Linux operating system. Even as you are a programmer or developer, even you can also contribute on your own, and you can launch your own Linux operating system as you are a distributor. So after adding few more components, few more add-on to the existing one. So in general, a standard pre-compiled sets of packages or distributions include the basic Linux system, which had system installation and management utilities, and other ready to install packages of common Unix tools. So generally, if you want to add your own, if you want to launch your own Unix product, Unix operating system as a product, then you may supposed to utilize these things. You download the set of pre-compiled set of packages, and you'll add your own into that, you'll attach into that, and you are going to launch it as your under your name as your distribution. So the first distribution managed these packages by simply providing means of unpacking all the files into appropriate places. So wherever you wanted to add, for example, if you consider while installing Linux operating system in your machine, so by default you'll get entire thing as a small package, as a RAR file or zip file. So during installation, the kernel will do all the exercise, that is unpacking all the files and putting it into proper designations, proper destination as well. So the early distributions, which is included SLS and Slackware as well. So right now in the market, we have Red Hat and Debian are popular distributions from commercial and non-commercial sources respectively. And we had a RPM package file format. So this particular RPM package file format which permits compatibility among the various Linux distributions. On the other hand, we can say the RPM package file format permits to add on few more performance related or component related as an add-on, and to it may provide a path to the Linux distributions. Coming to the Linux licensing part, so this licensing will be carried over by GNU General Public License, which is set by the Free Software Foundation. The Linux kernel is distributed under this license. So whoever using Linux or creating their own derivative of Linux, so may not make the derived product proprietary. So that software released under GPL license, the general public license, may not be redistributed as a binary only product. So this is one thing we supposed to take care. So if we are adding our own components, our own modules into this. Coming to the design principles part, as we know, Linux is a multi-user, multitasking system with a full set of Unix compatible tools. N number of users with n number of privileges can use the Linux, and it will be able to provide solution for many number of tasks, multitasking and multi-programming also, you can say parallel programming. So all these are the major principles or design principles, saying that if you are developing your own mechanism, then the Linux product or the Unix operating system that you wanted to develop, that must cope up with these things. It should be used by many number of users, multi-user capability, multitasking capability, and multi-programming capability, parallel programming capability, and other compatible tools. And the second principle is the file system mechanism. It should adhere to the traditional Unix semantics, and it should it fully implements the standard Unix networking model. They should follow, this file system should follows traditional Unix semantics, rules and mechanism, and it will implement a standard or default set as a Unix networking model. So the major goals are speed, efficiency, and standardization. Speed with respect to how fast your calculation should take place, how fast the program should give the results, how fast it should behave for the inputs, efficiency and accuracy, and a level of standardization should be maintained. So these are the main design goals. And in general, Linux is designed to be compliant with relevant POSIX documents, saying that at least 2 Linux distributions have achieved official POSIX certification. So the Linux programming interface adheres to the SVR4 Unix semantics rather than BSD behavior. So this is one of the important part that we supposed to look after. When we say POSIX, it is nothing but portable operating system interface. So the Linux should be compliant with this particular portable operating system interface. It is nothing but it is a family of standards, family of rules and regulations with the standards, which is specified by IEEE Computer Society, which is maintaining compatibility between different OS operating systems. So as a portable operating system interface. Moving further, coming to the components part, components of a Linux system. So these are the major components. Please follow my cursor. From left, top layer, we have system management program, we have user processes, we have user utility program and compilers. Then we on top of below that we have system shared library, Linux kernel, loadable kernel modules. So we'll see one by one. System management programs are nothing but the programs which helps to manage with the system, to manage with the file, to manage with the different other components of the system. So when we say system, for example, if you have a file should be created, file should be written, file should be updated, file should be deleted. So these are the some of the, as an example, as a management. So these are the some of the component which is supported by the Linux system. And coming to the user processes, various user processes based on the application to be executed in the backend, based on the program that should run in the front end as well. For all these kind of things, user processes should be supportive. So process should be started, be idle, should wait or sleep and terminate. So these are different layers. We have already seen that the different user processes should be executable or manageable with this particular component of a Linux system. Then we have some dedicated user utility programs. So when we say utility programs are nothing but which will helps in day-to-day execution of any other application, or it will support respective analyzing, configuring or optimizing in our regular Linux mechanism. For example, if we say user utility program, some of the analysis tools, configuration setup, configuring your storage, configuring your hard disk, virtual memory, increasing the speed via optimizations. So these are some of the user utility programs. So this is again the component of a Linux system. Then we have our compilers. Compilers on the other hand, we can say is nothing but a converter from higher level to object level. So to convert and to pick up with any language that is supportive for the programming. So using compilers, you can easily trace out or you can easily get the object files. So using these object files, machine can read this object file and get the result. So compilers are used as a converter to convert from high level language to the object file. That is in general as an example I say. Then we have system shared libraries. So this system shared libraries are nothing but set of functions, set of components as a system call. So that system call as a shared library which supports all these topmost components. So we need system file to create or to manage the file. We need system file to allocate the memory. We need system file or system. We need system calls or system shared library to allocate, to deallocate or reallocating memories, to create a process, to create or to run a process. For all these, we need system calls. So these system calls together we have in system shared library. So when we say system shared library, based on the program that is run in the front end, based on the individual application that we run, the system calls are identified. So based on that, this is derived as a group. Then we have a Linux kernel as a heart of Linux system. So Linux kernel, which is a free, again open source, it is deployed in a wide variety of computing systems under the license of GPL, and we may have different variants under that, and it is a main component of the Linux operating system. The major thing is it acts as an interface between computer's hardware and its internal processes. So it arranges communication setup between the hardware and its processes. As along with that, it will manage the resources as well to handle both hardware and softwares. Then we have something called loadable kernel module as a component. So these loadable kernel modules will help with this Linux kernel to load particular device driver for the hardware, to load particular API for a particular application, and so that it will contribute on its own for as a part of Linux system. So any doubt or any clarification, please get back to me. So as these are the major components of a Linux system, moving further with these components. So Linux is composed of three main bodies of code. The most important is nothing but the distinction between kernel and all other components. That is what we discussed. So here the kernel or the core is responsible for maintaining important abstractions of the operating system. On the other hand, we can say hiding, data hiding, so that nothing will happen to the core. Some abstraction should be maintained with respect to operating system. So kernel code, it will executes the kernel mode, executes in kernel mode with full access to all the physical resources of the computer. So this is something like with respect to, if I say administrator mode, So administrator will have all the rights, will be having all the rights in this all the softwares and the hardwares in the machine. So kernel code is nothing but which executes in this particular scenario, saying that kernel mode. So if you wanted to utilize this particular kernel mode, you are running your application in administrator mode, saying that you can utilize, you can access anything and all the physical resources in your computer. So how to go with that? Supposed to maintain in a single or same address space. So both kernel code and data structure related with this should be maintained or should be kept in same single address space. System libraries, which defines a standard set of functions, is what we discussed. Standard set of functions which may include built-in function, system call, so that the applications can interact with the kernel, so that the full privileges with respect to implement with respect to the kernel mode is not necessary. to go with any other application oriented things. So using the system libraries, the applications can interact with the kernel, something like API in general, if you say something like a system call. And the third major thing is system utility, which performs individual specialized management tasks like analyzing, configuring, optimizing. So these are as an example for these system utilities. Coming to the kernel modules part, few sections or sections of the kernel code that can be compiled, loaded and unloaded independent of the rest of the kernel. Some sections. So as can be treated as a separate modules. So what are these kernel modules will do? So each kernel module will implement a particular device driver or a particular file system or a particular networking protocol. So we may have for each IO devices one single device driver. For each memory, we may have a separate file system. For each communication, we may have a separate networking protocol. So these separate things are managed with the separate kernel modules. So that what are the main reason behind it? The main reason are it should provide an interface so that third party or whoever can write and distribute under the GPL. On the other hand, if we say the module interface allows third parties to write and distribute on their own terms, device drivers or file systems, but should not be shared. Kernel modules allows Linux system to be set up with standard, a minimal kernel without any extra devices, extra device drivers built in within that. So within minimal sources availability, so it can implement device driver, a file system or a networking protocol. So any clarification on this? So here we have a components of modules support. So these components, coming to individual components, we are discussing individual component that was we discussed over here. We'll coming to the individual components of this particular Linux system. We'll discuss one by one. Coming to the components part, so we had module management system, so which allows modules to be loaded into memory, communicated with the rest of the part of the kernel. So module to be loaded. So whenever we boot a system, automatically all the modules should be loaded into memory so that it can communicate with each individual IO devices. For this reason, we need loader and unloader. So this loader and unloader are provided by the module support using mode utilities. So when we have load and unload modules, so that it is easier whenever we boot our system, so that all the modules are loaded. Using unloader during shutdown process, all the modules are unloaded. On the other hand, released. So when we insert or when we attach a new input output device into our machine, there should be a registration mechanism so that that particular device driver uh, should be registered in our machines, saying that, for example, whenever you buy a new pen drive, after purchasing the new pen drive, at first whenever you insert your pen drive into your laptop or computer, so that particular device should be registered in your machine. So device driver should be installed at that time. So if you observe in the right bottom, clearly you can identify new device. A pop-up message may appear, new device found, installing device driver. Then it may say your device is ready to use. This is how registration process works in the backend. So driver registration system allows modules to tell the rest of the kernel that a new driver is available. Or on the other hand, if a new version of device driver is available in the internet, automatically the OS will inform you saying that new driver is available or an update is available for registration. Then as a major component of a module support, we have conflict resolution mechanism. So this conflict resolution mechanism which will help to resolve or to protect our resources both from accidental or mishandling by another driver. So when we say resources, maybe both hardware and software as well. So this conflict resolution mechanism or module which helps us to identify the conflicts, to identify the dilemmas, to identify any other hardware related issues with the machine. So as a major components of module support. Any doubt? Please raise. We'll continue in a short break by taking a short